Hello and welcome at this presentation about event-driven business automation, in which we will have a look at the Kogito platform. My name is Duncan. I'm a product manager at Red Hat. I've been at Red Hat for quite some time now, about 10 years, in various roles from consulting to solution architecture, evangelist, and now a product manager in the application services division. So today we'll have a look at Kogito but before we look at Kogito, we'll have a look at Quarkus, which is our cloud native Java application stack. And the reason we do that is because Kogito heavily utilizes Quarkus under the covers, and it draws some inspiration from the Quarkus approach to cloud native applications development with Java. After we have looked at Quarkus, we'll have a look at Kogito, and we have a look at the foundations of Kogito, the ideas and the methodologies that underlie the platform and the reasons why we have created this new project. After that, we will introduce event-driven business automation and what event-driven architecture can mean for business automation projects that define business processes, business rules, and so forth. And we will show two demos. One demo that shows how Kogito and processes and rules defined in Kogito applications can communicate with each other using event streaming platforms like Apache Kafka. And after that, we'll show a demo that shows how Kogito can integrate with serverless computing on Kubernetes and on OpenShift using Knative serving and Knative eventing. And after that, we'll look at the conclusions. So when we first look at Java, Java has been around for quite some time, and it's been the enterprise workhorse for quite some time, starting with concepts like J2EE, which later evolved into Java EE, which were mainly used to build three-tier applications back in the days that would run on a Java EE application server like JBoss Enterprise Application Platform or WebSphere Application Server, WebLogic, and what have you. But they were larger three-tier applications. Later, starting around the early 2000s, we started looking at concepts like services and service-oriented architecture. But nowadays, that has evolved into concepts like microservices, and everybody's doing microservices nowadays. But also microservices in the context of cloud native computing, where we start to deploy and package applications into containers that run on container platforms like Kubernetes, OpenShift, and so forth. So Spring Boot has a big market there, especially because you can create applications that are confined in a single jar file, which is easy to define with regards to its dependencies. It can be easily packed into a container image and so forth. Going beyond Spring Boot, we now can look at things like microprofile, things like serverless, event-driven applications, and so forth. And Quarkus has been introduced into the market as a project to solve a number of problems that Java has and has had in the past when it comes to resource utilization, and mainly things like CPU and memory. Java applications can be quite heavy on memory. They can take a long time to start up in the tens of seconds, 20 seconds, maybe up to a minute, and that doesn't really work well when you want to deploy applications, for example, as a function where you really want to have a container that spins up quickly, you can tear it down quickly, and that uses only the memory that it needs to execute that function rather than all the things around it to, for example, bootstrap the application, configure the application, and so forth. So that's why we introduced Quarkus. And the slogan of Quarkus is supersonic subatomic Java, referring to the super fast startup time that the platform has. Subatomic because it tries to utilize a lot less memory than traditional Java applications. It's been built by a lot of experts from cloud native Java open source projects. So open source projects like Eclipse VertX, Hibernate, RestEasy, Wildfly, Undertow, etc., etc. And these frameworks, these libraries are all combined into the application stack that we call Quarkus. So the differentiator for Quarkus in the market, it is basically that it takes a container-first approach. So it tailors your application for both OpenJDK, Hotspot, Java Hotspot, and GraalVM. So that allows us to do things like native compilation, where you can grab a Java application and compile it into a native executable. That gives us extremely fast boot up time and very low memory utilization, which really nicely fits the container world and also the serverless world for that matter. It has approaches to unify imperative and reactive programming models. For developers, it's great because it has a feature where we can do live coding. So what we can do is we can start up an application, a Quarkus application, in developer mode. And once it's running in developer mode, any change you make to the application source code, to your resource files, once you save them and hit the application again, the application automatically gets recompiled, redeployed, and your changes are available instantly within your application. And as I said earlier, it uses the best of breed libraries and standards. There's about 90 extensions to the Quarkus ecosystem as we speak. When we now look at the application stacks in the context of containers, and we look at traditional Java EE applications like applications deployed on JBoss EAP, Web Server Application Server, or Spring Boot, we can see that they don't really fit that nicely in the container world. Because of their high resource utilization, there are only so many workloads that or container workloads that you can fit onto a container node. And that's one of the reasons why more lightweight application programming paradigms and languages became popular in the container and the cloud native world, like Node.js and Go. However, when we now look at Quarkus, because we can greatly reduce the resource consumption when running, for example, Quarkus on a traditional JVM, we can fit more workloads onto the same amount of memory and the same amount of resources in our container world. And if we then look at Quarkus compiled to a native executable, we can even reduce those memory requirements, fitting even more workloads into a container execution node. Now, since you have to pay in a cloud environment for the resources you consume, being able to do more workloads in the same amount of resources obviously reduces the cost of the required cloud infrastructure. So what we can see when we look at a standard REST plus CRUD application, when we compare a traditional cloud native stack with a Quarkus stack on OpenJDK and a Quarkus application compiled to a native image using GraalVM and Substrate VM, is that a traditional native stack uses around 200 megabytes, where when we run it on Quarkus, we can reduce the memory requirements to about 130 megabytes. Now, if we then go to a native compiled application, we can even further reduce that to 35 megabytes, which means that we can fit almost 7 times more workloads into our container environment using a Quarkus native application compared to a traditional cloud native stack. When we then look at the startup time, we can see that the traditional stack takes about 10 seconds to start up. Quarkus and OpenJDK about 2.5 seconds. But when we then look at Quarkus compiled to a native image, we can see that that is reduced to a mind-blowing 55 seconds. And now that allows us to start thinking about the serverless space, where we could say, well, when a request comes in, we don't have the application running yet, but we just simply start up that container with that application, because it only takes 55 milliseconds to start up the app, serve the request, and then tear down that application again. And the second benefit I'd like to discuss is the developer joy, and especially the live coding. Because what Quarkus allows you to do is you can start up the application in Quarkus dev mode. And in that mode, you can make changes to a running application. So you can make changes to your source code. And once you save it and hit the application again, that code is automatically compiled and deployed on your application. So instead of having to save your code, run a build, deploy it on a system, deploy it on a server, and test it, you can now save your code and it's available immediately. Now, what Kogito provides on top of Quarkus is that not only works for source code and configuration files, but it also works for process definitions in, for example, BPMN2. It works for decisions defined in Drill's rule language or in DMN. So you can make a change to a process definition in BPMN, save it, and immediately test it on your running application. Where in the past and in the more traditional BPM systems, you would have to save your process, you would have to compile it into a deployment unit, you would have to deploy the deployment unit on an execution environment, and only then could you test it. So that reduces the round trip of making a change from around a minute to say a couple of seconds, which greatly increases productivity. So what about cloud native business automation then? So let's have a look at Kogito. So what is Kogito? So Kogito is our next-gen cloud-native business automation platform, and it's created to bring the business automation space, so business processes, business rules, business decisions, into the world of cloud and containers. Now, it's not a fully new project. It's actually a continuation of Drools, JBPM, and OptiPlanner, but it's being redesigned to be cloud native. So the engines underneath have been around for years. They are battle tested. They are proven to work in an enterprise environment, but are now redesigned to really work well in a cloud native space where, as I said earlier, you want to have fast startup times, you want to use as little memory as possible, and so forth. And one of the things we do is that we build on proven technologies like Kubernetes and OpenShift, and we really want to integrate as much as possible with cloud native frameworks and platforms that are really already out there without having to reinvent the wheel. So first about Kogito, about the name. It's pronounced Kogito. It's not Kogito. It's not Kogito. It's Kogito, and it comes from a Latin phrase, cogito ergo sum, which means I think, therefore I am. The reason I'm explaining this is because we actually had a Jira asking what the name actually means and why we have a winking pirate as a logo. So I have explained the name. Now for the logo, this is not Mario Fusco. It's not the our Drools project lead. It's also not a pirate, and it's also and the pirate is not winking either. So what it is, it's a Viking, and it's actually Odin who sacrificed his eye for knowledge. So that explains the logo and the name a bit, if you had any questions about that. So let's look at the foundations of Kogito and show you why we've created this platform. So the first one is cloud native. So why cloud native? Well, we saw that traditional BPM platforms are not really fitting well with how developers create cloud native applications today. So we want to go from a centralized, focused on BPM, focused on decision platform, to process automation and decision management as a capability. So what does that mean? We want to bring the capabilities of workflow management and the capabilities of rules engines and decision management closer to the application developer as capabilities of a microservices application. So we want to fit into how developers are building cloud native applications. And bringing Kogito as a building block on top of Quarkus allows Quarkus application developers to start using workflow logic and decision logic as parts of their microservice applications. And the other thing is what we want to do is we want to leverage more and better and integrate better with other technologies out there. For example, things like Knative and serverless, or things like Apache Kafka, or integrate with NoSQL stores like Finispan as a data grid to really benefit from all these great cloud native compute frameworks and platforms out there. So how do we do this? Well, first we build for Kube and for OpenShift. So we're Kubernetes native. Our main deployment platform is Kubernetes. The second thing that we do is we have a super fast boot time and a very low memory footprint, which basically we get by running on Quarkus and using GraalVM and Substrate VM under the covers. We're highly distributed. So one of the things that we really wanted to do, we wanted to move away from these very large process definitions that that you might seen in the past, where a process definition spans 120 nodes from one corner of the office to another corner of the office. We really want to go into that microservices philosophy where you say, well, we want to create an application that focuses on one specific thing and on one specific context. So we want to move from these large process definitions to smaller process definitions in the context of a microservice. And the same goes for decisions and for rules. And then distribute those, say, process or microprocesses actually across different microservices then can interact with each other either over REST or as part of the slog, obviously an event-driven approach where certain processes can send events that other process definitions or process snippets can react to. So we target two platforms, main platforms as our deployment platform being Quarkus and Spring Boot. So Quarkus is really the target platform for real cloud native fast, low memory utilization cloud native deployments, but we also know that there's a large Spring Boot ecosystem around there that we want to support. We utilize things like Kubernetes operators and OpenShift operators to automate the deployment of our distributed Kogito architecture. So that does not only include deploying and managing the applications, but also deploying things from the infrastructure. For example, InfiniSpan for persistence, or Kafka to provide the messaging and the eventing technology that allows us to send events not only within or in between Kogito applications, but also from the Kogito application to, for example, our data index service, which allows us to give us a search capabilities on top of our business processes. We provide a CLI that allows you to easily deploy your applications onto Kubernetes. And we now also fit into the Knative serverless paradigm, especially with our Quarkus and GraalVM native images that can boot up for example, decision service very quickly to do something like decisions as a function and decisions as a service. And we leverage many other and integrate with many other cloud technologies out there. So next is business domain. And what do we mean with business domain? Well, in Kogito, we want to focus on business domain rather than on technology. If you look at traditional BPM platforms and decision engines and rules engines, they usually already provide a RESTful API, but the implementation details leak through that API, which in the microservices world is not really something you want. And what do I mean with leaking of abstraction? Well, if you look at the REST APIs and the service APIs of these platforms, they have operations like start process, evaluate rules, insert fact, and so forth. And that basically leaks the implementation details through the abstraction of the service API, because you know from those APIs that there is a workflow engine behind it or that there's a rule engine behind your service. Now, with Kogito, we utilize the power of introspection at compile time to actually introspect your processes, your process definitions, your rules definitions, your data models, and so forth, and use that information to create and to generate business domain focused APIs for you rather than exposing more technical APIs like start process. This introspection also allows us to define context-based data searches, for example, to allow you to do searches on your process variables and the values of your process variables at runtime. So here is an example where we show you a RESTful API that has been generated by Kogito for a travels process. And as you can see, there's no operation like start process or abort process, but instead we have a post method for travel. So if you want to start a new travel, which is backed by a travels workflow, you simply post a travel. And when you want to retrieve then the information of that process instance, you get a certain travel by a certain idea. Below you can see a GraphQL interface, and GraphQL is the API we expose to do searches on your workflow instances and your, for example, your process data. So you can now look at the travels and then search for a travel of which the traveler is a certain person, which is pretty hard to do actually nowadays with traditional BPM platforms, to actually search on process variables and process data. And Cogito, by utilizing this business domain focus, allows you to do that. Then developer power. As I said earlier, we really want to bring those business automation capabilities for workflows and rules and decisions into the hands of developers. And we know that developers love using their IDEs like Visual Studio Code, maybe Red Hat Code Ready, Eclipse, IntelliJ, etc., etc. So we want to create, and we have created tools and design and tools and development tools that allow you to create these process definitions and create these decisions for Visual Studio Code. So that's available now in the Visual Studio Code marketplace, and you can check that out if you want. There is a Cogito VS Code extension that brings all that tooling into your VS Code environment. So embeddable tooling is very important for us to allow a developer of a microservice to be able to combine coding in Java with defining rules in, for example, DMN, or a part of your application logic as a workflow in BPMN2. As I said earlier, code generation. So we want to generate as much of the code for you as possible and as much as we can. So say, for example, that you use a message event in your BPMN file, and that message event actually needs to integrate with Apache Kafka, for example, to actually send that message to an event streaming system. You no longer in Cogito need to develop that logic yourself. So you basically define that message event, and with a number of configuration settings for the small reactive messaging extension of Quarkus, we auto-generate the consumers and producers that send those messages to Kafka and that consume those messages from Kafka. So it gives you simplified local development and debugging as well, because what we add to the Quarkus ecosystem is that live coding, and that I said earlier, where you can start your application in developer mode and you can change your application code and it automatically gets recompiled. That also works for business automation resources like business processes and rules. So when in Cogito, when you have your application running in developer mode, what you can do is you can change your BPMN2 definition, and that change gets automatically reflected in your application when you hit it the next time. So again, that greatly speeds up the development process. So here's an example. This is an example of the Visual Studio Code extension that we have, where you can see a business process definition within a Cogito application. And here, down here, you can see that we can start this application with a development profile to activate live coding that allows us to do things like hot replace. So when we change the BPMN2 file and we save that, that automatically gets hot replaced within the application without the need to compile, package, and deploy that process definition. So what about event-driven business automation? So as I said earlier, we utilize or we want to utilize best of breed technologies in the cloud native space, and we see that there is a lot of interest into things like event-driven architectures, where applications really don't talk directly to each other anymore by sending a request and expecting a response, but by sending events to an event streaming platform, and then have other applications and other microservices subscribe to these events that they are interested in, to allow them to, which allows much larger, greater decoupling between these systems. So event-driven architecture for Cogito is extremely important, and we started utilizing things like Apache Kafka actually from day one to allow our processes to integrate with each other using events. So for example, I'll show you an example in the travel agency application how that works. Other interesting topics are things like stream data integration, where you say, well, I've got a stream of events coming in and I want to integrate that with another system. but it might be that those events, you need to apply certain rules or certain decisions on these events to maybe transform them a bit, or to see whether they actually can be sent to that other system from legal and regulatory requirements. So that's where a rules engine, being part of a stream data integration pipeline, can become very interesting. And Kogito is a way in which you can define those rules and decisions into a small deployment unit that can integrate with stream data integration technologies like Apache Kafka, but also in things like Knative eventing streams and so forth. And finally, stream data processing, where you say, well, based on certain events that come in, I actually want to take certain decisions that can have a business outcome. So it could be, for example, fraud detection, where you say, well, I have a number of rules that I want to define in a business rules platform using business rules language, rather than a very low level technology. I want to utilize more business oriented business rules, but I still want to integrate that in my stream data processing pipeline to, for example, detect credit card fraud. And based on that information, based on that event processing, or maybe complex event processing, we can take different actions. For example, if we find a fraud in a credit card, we want to start a certain business process to further investigate that fraud case. Again, that could be implemented with something like Apache Kafka, combined with a Kogito application that is more focused on the business automation space, where we can implement these workflows and decisions using things like DMN and BPMN too. So if we look at the architectures from a centralized business automation platform that we see in traditional systems that I explained earlier, where you have really a centralized BPM runtime and various applications integrate with that runtime. Either they are called from that runtime, or they integrate with that runtime to see the current state of their process, or integrate with the task inbox of a process and so forth. And this is really a model where you have a process definition or a rules definition, and you deploy that on a centralized system. With Kogito, we really want to go more to a distributed business automation concept, where we say, well, we actually want to grab smaller parts of these processes and these rules and deploy them as independent microservices, and basically abstract that there's actually a workflow engine or a rules engine behind it. As I said earlier, if you have something like a decision that you need to take in a microservices, why would you do that in anything else than a decisions or a rules platform like Kogito? So that's what we want to do in distributed business automation. We really want to move away from that centralized idea to a distributed microservices architecture concept with Kogito. And if we then look at event-driven business automation, we can see that we now, with this technology, we can actually very easily send events to a queue or a stream, and also have the capabilities to consume events from an order or a stream. So in this example, you could, for example, have an order service that, once the order is placed, sends an order placed event into a queue or a stream that can then be picked up by a shipping service, for example, to say, well, okay, this order has been placed, and now I need to ship this order to a certain location. And using these streams and queues, or basically using an event-driven architecture, we can now decouple these applications from each other and have them communicate through events. And the good thing here is that that order event can then also, for example, be picked up by a promotion service, where you say, well, somebody placed this specific order, and we know that now that he or she is interested in that, and we actually want to apply a promotion for them now as well. Say, well, you ordered this, and maybe you're interested in these products as well. And if we look at things like Knative, same concept basically, but now we can use things like Knative event sourcing to grab events in Knative, send them through the Knative eventing brokers, and then have, for example, a travel service pick up these events and react on those events. We come to the demo. So the first demo that I'll show you is our travel agency demos. And what I want to show you in this demo is how we utilize messaging and how we utilize events in Apache Kafka to intercommunicate between different process definitions. So this demo is built up of two applications, a travels application and a visa application. And what you can see is when the process starts over here, we first do a visa check. And then we have a gateway that checks whether for this person a visa is required. Once a visa is required, somebody applies for the visa. So there's a human task that you need to execute to apply for that visa. And here's where it becomes interesting, or very interesting. This is a message sent event. And what we do here is based on simply this icon in your BPMN file and some configuration in your configuration file, in your application properties file, we generate a Kafka producer, a small reactive messaging producer, which will send a message to Kafka. Now, here is an event-based gateway, and what we see here is that there's two message consume events after this gateway. Either the visa is rejected or the visa is approved. Again, this creates a consumer on Apache Kafka on a certain topic. So what happens when this send visa application is sent to a topic, the other process definition is listening to that topic. And when that message is received, a new process is started. This process definition checks whether the visa can be approved automatically. If it can be approved automatically, it sends a visa. It ends with a message end event. So this again sends an event to Kafka. And if the visa cannot be approved automatically, there's a manual visa approval step here. And then depending on the outcome of that, either the visa is approved or the visa is rejected. So these are again message end event that send events to, in this case again, a topic on Kafka. Now, the visa approved event is sent to a visa approved topic. The visa rejected event is sent to a visa rejected topic. And depending on which message is sent, either visa rejected or visa approved, either this path within the process is taken on the receiving of that event, or this part of the process is executed. So you can see we have splitted a business process that encompasses a travel and a visa process into two different microservices, so two different services. So the logic is separated, and they can be created separately, they can be evolved separately, and so forth. And there's no direct communication between these two process definitions whatsoever. But we communicate, we have these processes communicate with each other using events over Apache Kafka. So let's look at that in detail and how that works and what that looks like on a platform like OpenShift. So when we now go to OpenShift, we can see that we've got the Kogito operator installed here. We also have the InfiniSpan operator, the keycloak operator, and the strimzy operator, which allows us to deploy Apache Kafka onto our cluster, into our namespace. So when we click on the Kogito operator, we can see that we have got the Kogito infrastructure deployed. So that means Kafka and InfiniSpan for persistence. We've got the management console deployed, and we also have our data index service deployed here. When we look at services, we see that we have the travels microservice and the visas microservice deployed, which implement the processes that we saw earlier. Now we can see in our deployments that we've got a bunch of deployments here, including things like strimzy, management console, and our two services. And we have got the routes to, among other things, our services here. So let's go to the travel service, and we plan a new trip. And we can now see that we've got our trip booked here. When we now look at the task, and remember, first human task is to apply for a visa, we can see that there is a visa application here. So recall that when we apply for that visa, then the next task is that a visa application a message is being sent to Kafka. And to demonstrate that, I've got a Kaf drop instance running here connected to my cluster actually. So there's a visa applications topic, as we can see here, a visa is approved and a visa is rejected topic. So let's go to that visa applications topic and let's view the messages. So we can see that there are no messages here right now. So let's now complete our application. So before we do that, we go to the visas application as well to show that we're not cheating. There are no applications here. So we go back to the travel agency here and we click on apply, and then we enter our passport number and the duration of our trip, which will be 40 days, and we're going to submit the application. And when we now go back to the Kafka topic and we do view messages, we can see that a message actually has been sent to Apache Kafka using the cloud event message type here. We can also see that our visas application now has a new application here. And that's because the start process of our visa application, as we've seen earlier, was actually a message start event, which is listening to that Kafka topic and will start a process instance when it retrieves a message. So we're not going to look at approval. So there was no automatic approval. So we're going to approve. And again, we can see in Kaf drop here that we have a approval top visas approved topic and a visas rejected topic here. So let's look at the visas approved topic and view the messages. There's no messages there. So when we now say we're going to approve this specific visa, we can now see that there is an approved message in this topic. We can see here the visa application, and we can see that the approved Boolean has been set to true. And now we can also see that when we go back to the travel agency, that the visa has now been approved. So if we've retrieved the message and a hotel has been booked and a flight has been booked here. And we can go to tasks and we say complete. We're going to confirm that travel. And once we do that, we can see that the process has been completed. So we can get a bit more information from our environment by going, for example, to our data index service. So that allows us to do these domain-driven queries across our data. So we can actually check whether which travels we have seen in our environment. So we've got one travel being booked with this ID. We can now look at the, for example, the traveler, and from the traveler we can, for example, see the name, last name, email, and so forth. So we can also do context-based searches on this, and we can do searches based on the travel, on the traveler name, and so forth. But apart from the domain-driven and the domain-focused APIs, we can also look at the process instance. So for example, if you're an administrator, you might actually want to see the actual process instances rather than the domain data. So we can see here that we've got a number of process instances here, actually 4. We can look at the process name. And maybe also we also want to see the process ID here. So we can select that, and we can see that we had a travels process, and the travels process initiated a visa application process. And once that was completed and we went back into the travels process, there were 2 sub-processes, one to book the hotel and one to book the flight. Now, and finally, we've got the management console here for Kogito, which shows the, we can search for completed once we apply the filter, and we can see that we have a number of processes that were completed. So the travels one here and the process visa application here, and we can see a number of sub processes as well, the flight booking and hotel booking, which were the sub processes for the travels process, and we can look into details and actually look at these process variables. We can see the values of these process variables, the structure of the JSON, as well as the flow through the process definition here. The wait for decision, for example, the fact that the visa was approved, booking the hotel, booking the flight, and so forth. So this concludes the first demo on OpenShift with the travel agency, and we will now take a look at the second demo, which is a demo in which we're going to look at the integration with Knative eventing. And in our Knative demo, we have again a business process that we will trigger in this case via a RESTful request. And depending on the data that we give it, we can either process the travelers or we can't. So the decision is made in the rules here, and then we have a gateway that says, well, if I can process the traveler, I will log this traveler and I'll send a message here. And if we can't process the traveler, we simply skip it. And what happens is that this process traveler message end event actually uses a Knative sync binding to send a cloud event to the Knative broker. And to the Knative broker, we have attached a Knative trigger, and that Knative trigger will then trigger a Knative serving service, an event display service. So this will be automatically, the pod will automatically be created by Knative serving, and when it's no longer used, it will be automatically shut down. So what we'll do is we'll send a request here, and then we'll see hopefully the event display pod being triggered by Knative serving, and we can see the data flowing through the Knative system from the sync binding to the broker via the trigger to the event display pod. So when we look in OpenShift, we can see our Kogito process and microservice being deployed here. So what will happen, we'll send a request to this microservice through its route that will then process that request, and through the sync binding, then send an event to the Knative broker, which then will trigger that trigger and then trigger the Knative serving service event display service that you see here. So we can actually show that there is no event display pod running right here. So what will happen is that when that event triggers that service, it will automatically spin up a pod here. What we can also show is that we have got our sync binding deployed, as well as our Knative broker, and we have got two triggers here as well, and we're going to use the event display trigger one here. So let's see if it works. We'll send a curl request, a post request to the Kogito service. And if everything goes well, we should see here, and yes, exactly, we see an event display pod being started here by the Knative serving framework. So if everything is correct, we should see the data that we've sent here back in the cloud event that's been sent through Knative eventing to our service. So let's check that out. So we can see the pod here. So let's look at the log of that pod. And because this pod has got multiple containers, we need to specify the container name. And indeed, we can see that we've received a cloud event here with the data that we've sent right here. And we can see that the process boolean has been set to true. So our Kogito application sent an event to Knative eventing, and eventually that ended up in the Knative serving service event display service that we see here. Now, if we wait some time here, and we can already see, because there's no more requests coming into the event display service, Knative serving is now terminating this pod and scaling this functionality back down to 0. So this concludes our Kogito and Knative demo. And this concludes our session on event-driven business automation with Kogito. What we've seen today is that Quarkus enables Java to excel in the container and cloud world. Also, Kogito delivers a true cloud-native development and runtime business automation environment tailored at container platforms like OpenShift and Kubernetes. Kubernetes and OpenShift facilitate the deployment and management of potentially complex distributed architectures. And the out-of-the-box integration with Knative and Kafka enables event-driven process automation and decision automation architectures. I hope you've enjoyed this session. Thank you for listening.